So we're just starting out with our lab and we are designing Joe's network for him. We're on step one where we're going to come up with the IP scheme. Now obviously our IP scheme will use RFC 1918 private IP addresses. If you don't use those private IP addresses on your private network, then you really deserve to be smacked around a little bit because you're only making your life more difficult when you finally do have to actually route traffic to IPs that live on those public IPs that you've stolen. So let's look at the requirements. Network 1 has to support 150 users. Network 2 has to support 25. Network 3 has to support 50. And while it might be tempting to say, well, Class C is everywhere, that's the easiest thing to do. And in a real-world scenario, that's probably what you would end up doing just to allow for proper expansion. Let's meet the requirements of the lab, because a lot of times when you're taking exams, this is exactly what you'll have to do, and say, well, what's the smallest network we can get away with and still support all of these users? Obviously, these networks are going to be smaller than a Class C for the most part. So let's start with the smallest network first. Sales has 25 users. So what I've done here at the bottom, I paused the video while I did it, is I've built out our little bitmap that we talked about when we discussed subnetting. And you'll see we started with 128 over here on the left, and we go down by powers of 2, basically cutting it in half, till we get all the way over here to the end. So the easiest way that I do this, if I have to support 25 users, I go from the right and go towards the left until I hit the number that is the next step above my requirement. So 1, 2, 4, 8, 16, 32. So in this case, we will extend our Class C subnet mask by 3 bits to make it a /24, 25, 26, 27. So this first network will be a /27 network. So we'll go up here and we'll do a little note here next to sales and we'll do /27 network. So let's look at the next biggest network. Research and development has 50 users. So if we do this, 1, 2, 4, 8, 16, 32, 64. We can't use the 32 because there's 50 users. So we go the next step up, which is 64. So in this case, it is a /26 network. So let's go up here and do /26. Next, the largest network has 150 users. Well, obviously that has to be an entire Class C network because the biggest one we can get is 128. And we have to use all of these bits all the way up to 128 in order to support 150 users. So this one is going to actually be a Class C, a /24 network. So that takes care of all of our LANs at each of these locations. What about these point-to-point links? Well, obviously they're point-to-point, so you only have 2 IP addresses on them. However, you can't use this /31 network because you have to have 1 IP for the network and 1 IP for the broadcast. So the smallest network you can actually have and it be usable is a /30 for 4 valid IP addresses. So we'll make another note down here along the bottom. P2P networks are /30 networks. So now that we have the subnet masks that we're going to use for each of these networks, let's come up with a comprehensive IP scheme. So we'll do HQ. Since it's an entire Class C, we'll do 192.168.10.0/24, which means that the subnet mask up here will be 255.255.255.0. Sales will be 192.168.11.0/27, which means its subnet mask will be 255.255.255. What? What's the last octet here? Well, again, we just have to add up all of these 3 subnet mask bits that we're using. So 128 plus 64 is 192, and 192 plus 32 is 224. So that means the subnet mask up here will be 255, 255, 255, 224. Finally, R&D will be 192.168.12.0/26. In this case, we already know what 1 bit less than the 224 is. It's 192. So we know its subnet mask is 255.255.255.192. Now all that's left are the point-to-point networks, and even though we could break up the .13 network into much smaller networks, we'll do .13, .14, and .15, but we will limit the subnet mask. So point-to-point 1 will be 192.168.13.0/30. That subnet mask is one that you'll memorize just offhand. It ends in .252. So we'll do P2P2 will be 192.168.14.0/30, and P2P3 will be 192.168.15.0/30. So when we're done, we should see all of these networks and all of the routing tables throughout our network. But we won't get there yet. First, we have to go into each of the routers and configure them. And we'll do that starting in the next video.